Hey guys, so this week is our last week, at least until we meet back up in the fall. But we're going to talk a little bit about equivalency and how that relates to some specific questions on the PSAT that deal with equivalency. Okay, so when we talk about equivalency, we mean two things in math, at least like in math. Equivalency has obviously other definitions, but when we talk about it in math, we mean something like this, that 2 cubed is the same thing as 8. So 2 cubed obviously looks different than 8, but they equal the same thing. So we would say that those two things are equivalent, okay? And you have seen some equivalencies in your classes so far when it comes to lines, parabolas, and circles. That's what we're going to get to in this short video. So for instance, you all would be able to give me the equation of this line in slope-intercept form. And I'm sorry for my handwriting being kind of terrible there, but slope-intercept form says I just need the slope of a line and the intercept, and that gives me an equation of a line, y equals mx plus b. So my slope here, if we count this out, is 1/2. And my y-intercept is 8. And so there's our line in slope-intercept form. We have another form that we could write our line in something we call point-slope form. In calculus, this is a form that we most often use, point-slope form. And so this is still an equivalent answer, but it just looks different. And in point-slope form, we typically need a point, so we can use the point 0, 8. And the slope 1/2. And when we plug it into our point-slope form, which is y minus y1 is equal to 1/2 x minus x1, we can do that. And so we don't have to do any manipulations on this. This is equivalent to this guy. All right. And then we have our last form. We have what we call standard form, which has its uses, but, still equivalent. Maybe we don't use it as often, but it's still equivalent. And standard form just says, hey, get rid of fractions. We don't like fractions in our line. So what we can do is actually use our slope-intercept form. And if I get rid of 1/2 by multiplying everything by 2, then I end up with 2y equals x plus 16, or I can say that 2y minus x equals 16. And here we have our standard form. So each of these forms is equivalent to each other, even though they may look different. And sometimes we have to do some algebraic manipulation, as we did here in standard form, so that we can find an equivalent answer. Let's go to parabolas. And typically we see parabolas in a couple of forms. Our standard form is like this: ax squared plus bx plus c. But we're actually going to start by finding this in factored form. Okay. So factored form of this parabola would be y is equal to x minus 3 and x plus 2. And I'm actually going to scoot this part over a little bit, because what I actually want to do is we're going to need to solve for a. We need to figure out what that value of a is. So we're going to use a point on this parabola to solve for a. And I'm going to choose a point that's like relatively easy for me to manipulate. So we're going to go with the point 2, -4. All right, and it's okay if you don't have like this parabola. You can, kind of do a quick sketch on your notes in front of you. That's fine. But we're going to use 2, -4 to solve for that value of a. So my y value is -4. We have a. We have 2 minus 3. 2 plus 2. -4. A. 2 minus 3 is -1. 2 plus 2 is 4. And so we have -4 equals -4a. A equals 1. Cool. So here's our factored form. Y equals x minus 3, x plus 2. Okay. Another equivalent form that we can go to is our standard form. And we can do that by distributing. So standard form. And when I distribute, we end up with y is equal to x squared plus 2x minus 3x minus 6, or x squared plus, minus. All right, so there's our standard form. And we also have our vertex form. So far, this thing is equivalent to this thing. And vertex form requires us to do some... I know that we have the vertex listed here, but I'm just going to show us like how, just to remind us how we can get from a standard form to a vertex form if we didn't have the parabola in front of us. So if we didn't have the parabola, we didn't know what the vertex was, that's what we're going to assume right now. So remember, if I have a standard form, I can actually set that equal to 0. I'm going to add 6 to both sides, so I have x squared minus x equals 6. And then I want to complete the square, so I need to complete the square here, and using this term, my coefficient is 1, so half of that is 1/2. And then when I square that, that gets me plus 1/4, or 0.25. And if I add 0.25 on one side, I have to add 0.25 on the other. And so now the left side of that equal sign can be written as x minus 0.5 squared equal to 6.25. And my vertex form is x minus 0.5 squared minus 6.25. So again, here are 3 instances. Very sorry about that. That is my dog playing with a golf ball. Here are 3 equations that mean the same thing, but are different. Okay, so equivalency. And you'll see these pop up every once in a while on a PSAT question. And then the last one is circles. Okay, so typically when we talk about circles, we graph them in what we call vertex form. That was my dog. She just tore down the fan. We're going to keep going, and she scared herself, so that's weird. Vertex form. So, not really vertex form, it's really we're using the center. So the center of this circle, if we look at it, is at -7, -5. And by doing that, we also see that the radius of this circle, because we found the center, now we can find the radius. The radius is 2. So one form of our equation we can write as x plus 7 squared plus y plus 5 squared is equal to 4. And we're using this form of a circle, x squared plus y squared equals my radius squared. So there's one way to write the equation of this, and when we have the center that's not at 0, we're saying x minus h squared, y minus k squared equals r squared. And then another way that we can write this is in what we call standard form. And standard form basically says, well, what if we expand everything out? And we move all of our terms that have a variable in them to one side, and all of the terms without a variable to the other side. So I'm going to subtract 49 and subtract 25. So 4 minus 25 minus 49, negative 70. And so we have another form. So these two lines, or these two equations, they refer to the same circle, okay? If we wanted to manipulate this backwards, if we wanted to go from here to here, we could complete the square. And if we completed the square, we would see that we would get back to that vertex form of our circle. So I wanted to start this discussion out talking about equivalency and some forms of equivalency that you have already seen in math, okay? And so I wanted to kind of start this video and this week with this video so that the rest of these questions make sense, okay? So this is the end of video 1. See you in the next video. Hopefully my dog won't cause a big ruckus. Sorry about that.